It's 309 million years ago during the Carboniferous period of Earth's history, and you are kayaking through a shallow ocean inlet off the coast of tropical Pangaea. You are here to witness some of the strangest ocean creatures ever to exist. Certainly, there are many other curious and unfamiliar oceans throughout deep time, especially during the early establishment of animal phyla. However, you've chosen this particular place and time, called the Essex fauna, because there are so many animals here that are outright unclassified, at a time when many organisms were becoming well understood. Your previous excursion to the Carboniferous took you to the endless humid forests of Mason Creek and the freshwater animals of the Braidwood biota, but today you are concentrating on marine critters. So, life fest on. You take your kayak paddle and start to explore. It's a calm day with a wispy blue sky, and the gentle water makes a pleasing sound against the hull. The sea breeze smells energizing. Scattered boulders create wave breaks and rock pools clustered with brachiopods. Far away, a sandbar creates a wave break against the deeper water of the open ocean. Further back to shore is the bristling coal forest, standing tall, buzzing with insects, a fortress of mist and foliage. The water is as deep as a human standing, but you see with crystal clarity the puzzling world below. What is that? Look below you. Something curious is swimming awkwardly about the size of your hand. It's unlike anything you've ever seen before, or will ever see again. It's H. Well, that's its nickname. This H, a living letter, has 4 flappy tentacles that stick out at right angles, too long and too short, and a central sac structure that pulses as it swims. Its real name is called etacystis communis, in Greek translated to the H-sac. So what is it? An octopus? A jellyfish? Basically, we have no idea. It hasn't even been formally placed in a phylum yet, but paleontologists are leaning towards calling it a hemichordate acorn worm. If it's a terabranch hemichordate, which always grows colonies, then it's proposed that H might also link together to form colonial chains. Does life get weirder than that? You paddle a bit, accidentally creating a current that spins H out of control. The sandy seafloor below is fluffy and white, and the water is turbid from the brackish river delta that feeds into the ocean. Life here is amazing. Look down there, small snails called euphormites drag themselves across the sand, leaving imprint trails. Past bivalves called mesonomia, nicknamed clam-clams. A small sea scorpion called Adelophthalmus undulates past, irritating a horseshoe crab called Liomisaspis. The sediment is covered in worms. There's Chaetognatha, a carnivorous arrow worm, as long as your arm and armed with hooks and fins. That is Mesophorusa, an annelid called a fan worm, and there, the horrendous-looking spiky paleocamper, named the ancient caterpillar, complete with venomous spikes. It's one of the last surviving lobopods, an ancient lineage that's a throwback to the Cambrian. Is this real? Another letter of the alphabet? Planted in the sediment, you see another mysterious creature. Meet Y. Its scientific name is Escumasia rorii, and while at first glance it seems like some kind of anemone, it's another unclassified thing. It is attached to the seafloor by a stalk, with 2 arms that don't appear to have any capability for filtering, feeding, or grasping. It has stinging cells called cnidocytes like a jellyfish, but it's not a cnidarian because it has a complete digestive system. This shallow ocean zone is a haven for beautiful fish. Look at that Pinocchio-nosed chondrichthyon sweeping past at high speed. It's Bandringa, an elasmobranch, an early shark ancestor. It's only as long as a pencil, and half of that length is its nose. Fish like Bandringa and the flat ray-finned Platysomus were diversifying after the relatively recent late Devonian mass extinction. These shallows are home to many curious specimens, including some primitive forms. There goes a Myxonicella flitting past, a jawless hagfish. And there, a related lamprey called Pipisias, with a crown of radial teeth, with the strange nickname of Push Me, Pull You, so called because both ends of it look so alike. There goes another chondrichthyon called Polycentaur, with a big bulbous head. It's part of a chondrichthyon group called the holocephalans. They're not sharks, and their modern-day descendants are small fish called chimeras. They were extremely abundant during the Carboniferous, and they include the terrifying buzzsaw chondrichthyans like Sarcoprion. You won't find any big ones in this shallow ocean haven, but they're out there in the open ocean, somewhere. Polycentaur glides past near tiny crustaceans called Conchovicaris, big-eyed creatures called thylacocephalans, and beyond, tumbling in the surf, you see the heavy-duty shell of a tough ammonoid, Titanoceras. As you paddle towards the rock pools, small shrimp called Bilotelson and Tyrannophontes flicker across the sand under a bloom of reticular medusa jellyfish. And if you look closely, you spot minuscule octomedusa, jellies with 8 stubby tentacles. A little creature bumps into your kayak. It's some kind of blob with 10 arms. Pohlsepia was once believed to be the oldest known octopus, but besides the tentacles, it has no beak, hooks, suckers, or any other cephalopod anatomy. It's another giant question mark of deep time. You pull your kayak up to a porous black rock and hold onto it to steady yourself. Foamy white water pours out of crevices, and a tiny trilobite called Ditomopyge walks around near your hand. The water is still as deep as your chest, and down there are Bilotelson shrimp, and mysterious sac-shaped things called Essex that were once called jellyfish, but are now maybe anemones. And chasing the shrimp away, you see one of the most bewildering of all Carboniferous animals, one of the few prehistoric animals scientifically referred to as a monster. That is Tully monstrum, the Tully Monster. It's... well, what is it? It has a body shaped like a torpedo, with a grasping claw on the end of a long appendage. Sticking out sideways are 2 protrusions that are probably eyes, and it has fins on its tail that it uses to steer. So, is it a vertebrate because of its eye structure and what look like gills? Paleontologists are throwing the whole toolkit at it to try and find out. Scans using X-ray computed tomography have shown its muscles don't have myomeres, a characteristic only found in chordates. It lacks any form of skeleton, including the notochord, and also has different melanosome pigment cells than what is commonly seen in vertebrates. And generally, no other vertebrate has this body plan, so it's probably not vertebrate. If it's an invertebrate, paleontologists haven't been able to pinpoint which one. Is it a mollusk, like a squid? Some kind of worm? Or an ancient arthropod like Opobinia from the Cambrian? Or does it belong to a group of animals with no descendants? We don't know. It's time to leave this strange ocean of mystery animals. We might never be able to classify etacystis, escumasia, Tully monstrum, and pohlsepia. But the world in which they lived, together with clams, sea scorpions, push me pull you, Bandringa, Octomedusa, arrowworms, and Paleocampa will hopefully be remembered as one of the most curious ecosystems of deep time. As a wave hits the kayak and you readjust your grip on the porous rock, you feel a sting. It was why? It stung you with one of those cnidocytes. If that's a Carboniferous ocean souvenir, it's not a very pleasant one. I hope there's a doctor somewhere in the Carboniferous that's familiar with prehistoric stings. We don't want to bring back some kind of ancient infection back to the modern day. So, what do you think? Could this be the strangest ocean in prehistory? But then again, aren't all oceans strange? If you're interested in learning about the worlds of deep time, make sure to like and subscribe.